That's right, it's time for math class. All right, we're starting Unit 6. Although we're only doing, remember, the first part of Unit 6, just 2 lessons, but this will carry on throughout the whole week because we have NWA testing tomorrow. So Lesson 6.1, it's on volume. All right, to remember volume, we have to review what area is. All right, so on area, if we have a rectangle that is 2 units by 3 units. The area is the space within that two-dimensional figure. So 2 means units, the rectangle is 2 units long on that side and 3 units long on this side. So when we put that together and make the lines, how many square units are inside? Well, if we count them, there are 1, 2, 3, 4, 5, 6. Well, we can use a formula because we know that 2 times 3 equals 6. So when we're finding the area, we're going to take the length, okay, which is the 2 in this case, times the width to find the area. The length times the width will give us the area, the number of square units on the inside. Okay, and we're going to carry that into what we now do for volume, because now we're just going to add the third dimension. Okay, let's check this out. Turn in your books to page 231. Let's talk about what a cube is for volume, because what we're going to be doing, instead of finding the square units and like we do in area, we're going to be finding the cubic units. So we have to understand what a cube is. Look at the cube down here, putting a square around it in blue right now. That cube has described what each piece is. The corners, where all the lines connect, is called the vertex. One of the sides are called faces. And then the edge would be the line, the actual measurable lines that are put together. So let's answer some questions. Number 1, how many faces does a cube have? Think about a dice, okay? How many numbers are on a dice, which is a cube? There are 6. 6 sides to a dice. 6 sides or 6 faces on a cube. Okay, how many edges are there? All right, I'm going to try to draw this. Let's see how I do. Make this part bigger while I draw it. Okay, if I take the front face, there's 1, 2, 3, 4 edges on the front, which means on the back, that's 4. On the back side, which would be this side and that side, there's also 1 on the bottom that we can't see right now, and 1 on the back side. That'd be another 4. And then connecting those, there'd be 1, 2, 3, and then back here there'd be another one. So if we drew this part where you can't really see it, there will be another 4 connecting them, which equals a total of 12. There are 12 edges. Oops, go back to the pen. There are 12 edges on a cube. Okay, 6 faces, 12 edges. Let me see if I can get rid of this. Oh, it won't let me erase it. That's all right. Now, true or false? I'll change the color of those answers so you can tell the difference. All the edges of a cube are the same length. Look at the cube. For it to be a cube, all the edges have to be the same length. There are 12 edges, all the same length. So if you know the length of one of them, you know the length of all of them. If you measure one edge on a cube, you know all 12 of them. That is true. All edges are the same length. All the faces of a cube are congruent squares, which means squares that are the same size and same shape. Well, that is the definition of what makes it a cube. For it to be a cube, all 6 faces must be the same size and the same shape. They must be congruent. Okay, cube, perfect cube, means 6 faces that are squares that are all the same size, and all 12 edges are exactly the same. How many vertexes are there? How many vertexes are there on a cube? Figure that out. How many vertexes? Vertex. How many of them are there? See if you're right. 1, 2, 3, 4, 5, 6, 7, 8. There are 8. vertexes on a cube. All right, let's move on to the next page, or the rest of this page. All right, let's explore what it looks like to create a rectangular prism. A rectangular prism would be, if we looked at it from the top, it would look like a rectangle if we look straight down from the top. But now we're going to see it from the side so we can see that it is a rectangle that is now going up. So we take the length and the width and we're adding height to it, okay? The first layer, each layer of the rectangle prism is 4 cubes by 2 cubes. So we have 4. Let me see if I can blow this up for you. We have 4 across this side and 2 across this side. Okay, now, how many cubes make up each prism? 4 times 2 is 8. And our one layer means the height, that third dimension, is only 1. So 2 times 4 times 1. Because we're going to learn that volume, give you a little sneak peek, what we're doing later, volume is equal to length times width, which is the area, but now we add the height. So we take area, find the area, and then multiply the height times that. Or all 3 dimensions together, length times width times height, which means you can multiply them in any order. Okay, what happens when we have 2 layers? Well, here we have, again, 2 on this side, 4 over here, but now what's the height? The height, which I'll write in red, is 2. So now 2 times 4 is 8, and 8 times 2 is 16. How many cubes are there? Well, there's a row of 8 and another row of 8. 8 plus 8 is also 16. Okay, now we're going to have a pattern here. Again, we have 2 times 4 times 3. So the base layer is 8. 8 times 3 is 24. Notice one more layer, we increased by 8. 16 plus 8 equals 24. The height here is 4. So we have 8, which is 2 times 4 again. We keep repeating these two because that's the base. The base is on all these is 2 times 4. 2 times 4 is 8. 8 times 4 is 32. Notice the pattern. We're going to add 8 more each level. 8 more than that is 40, and 8 times 5 is 40, and 8 times 6 is 48. Okay, let's practice some of these. Pause your video and complete 6 through 11 right now. Go. All right, let's see how you did here. All right, 6, 4 times 2 is 8. 8 times 1 is 8. 7, 4 times 2 is 8. 8 times 2 is 16. 3, 4 times 2 is 8. 8 times 3 is 24. Notice we're getting the same numbers as up top. 4 times 2 is 8, and 8 times 4 is 32. 4 times 2 is 8, and 8 times 5 is 40. And 4 times 2 is 8, and 8 times 6 is 48. Okay? Volume. We're just adding one more dimension. We do the area, and then we now multiplying the height times that. Okay? All right, let's look at the next page. Turn the page to page 232. Developing a formula. Now I've already given you a sneak peek of this. What is the volume of this rectangular prism? Well, again, we're going to look at the bottom, and the volume is going to be equal to the length times the width, which is the 2 dimensions for the bottom, and then we're going to add multiplying by the height. Okay? And in this case, that's going to be volume is equal to length 5 times the width 2 times the height 3. What is the area of this prism? Well, 5 times 2 is 10, and 10 times 3 is, the volume is equal to 30 centimeters, because this is in centimeters, and now just like area we did squared, but in volume we do cubed, because we're talking about 3 dimensions. Okay, length times width times height. Okay, and if we look, we see we got 5 across here, 2 here, that's a layer of 10. So we have 10 across the bottom, 20, and 30. So when we count them out, that's 30 cubes, which means 30 centimeters cubed, because these are cubes that are a centimeter by a centimeter by a centimeter. Okay, now look at number 13. It's asking you to write a formula. We've already done that for the regular one. We've got that at the top. But there's another one we got to know. Okay, we know that volume is equal to length times width times height, right? But if I take this and put the length times the width in parentheses, what does that mean? That means it's the area of the base. That's the area formula we have from our area, which is the bottom. Okay, so if I take that and rewrite the formula as volume is equal to that part in parentheses as a capital B, the base of the prism, because that's the area. You can also have volume is equal to the base, which is the length times the width times height. So when you see a capital B, like right here, that means that's the length and the width, the base of the rectangle. The base can be measured in an area, and then you multiply the height, which makes it volume. Okay, so you're going to see it two ways. You're going to see a volume formula like this, length times width times height, and you will also see volume as this, base times height, because sometimes they'll tell you, for example, let's look at number 14 right here. A box shaped like a rectangular prism is 4 decimeters long, 2 decimeters wide, and 3 decimeters tall. If I asked you not just what the volume is, what's the area of the base, we would look at 4 decimeters long and 2 decimeters wide, length and width. So we could say that that part, the base, is 4 times 2 is 8. That 8 would be equal to the base, capital B. And then that 8 times the 3, 8 times 3, is 24, and that would give me the volume. Volume is equal to 24, and this is decimeters cubed. All right, so let's give you a chance here. Look at 15 through 18. I want you to pause your video, work on 15 through 18 right now. Again, you're finding volume, length times width times height, or you could be using base times height, but most of these will be using length times width times height for now. Pause your video and get started on 15 through 18. We'll be back to correct in a couple minutes. All right, let's take a look at some of these. All right, number 15 says, when closed, the cargo area of a truck measures 3 meters long by 2 meters wide by 1 meter deep. How many cubic meters of cargo will fit in the closed area? Well, we're going to say that the volume is equal to length 3 times width 2 times depth, which is also sometimes height when we get that formula together. It can be somewhat confusing. When we think about it, sometimes we're looking at how they'll measure the front as the base, and then how deep it is how far back it goes. Okay, so either way, you have the 3 dimensions. 3 times 1 is 6, and 6 times 1 is 6. So the volume is equal to 6. We're talking about meters, and again, we're talking volume, so it's cubed, 3 dimensions. All right. Let's look at number 16. A flower box is 3 feet long by 2 feet wide and 1/2 foot deep. When you multiply by the fraction 1/2, we cut it in half. So we have the volume is equal to 3 times 2 times 1/2. So the volume is equal to 3 times 2 is 6. And what is half of 6 is 3. Okay? It might be confusing, but now you know when you multiply by half, you cut it in half. When you multiply by a fraction, you actually divide by its reciprocal, but we'll talk about that later. But for right now, the only thing you have to multiply is by half. That means just cut it in half. We did that when we did triangles before. The measurement is feet. 3 feet, and again, that's cubed. Okay. Number 17. Cubes of fudge are arranged in 2 layers on a tray. Each layer is 8 cubes long and 6 cubes wide. How many cubes of fudge are on the tray? So we've got 2 layers, which is too high. So we have the volume is equal to 8 cubes long times 6 cubes wide, and that's our base. And then we have 2 layers, or the height of 2. So 8 times 6 is 48, and 48 times 2 is 96. Now this is not going to be asking how many feet. It's not a measurement, but it's taking the number of cubes. So we would say 96 cubes are on the tray. 96 cubes. Okay? All right, let me move this up just a smidge so I have a little more room to work here. There we go. All right, Todd used 8 small cubes and glue to build the cube shown at the right. Then he painted the entire cube red. After the paint dried, Todd broke the cube apart into 8 smaller cubes he started with. How many faces of the 8 smaller cubes are not painted red? Now this one is going to be talking about the faces. So we know how many faces are there on one cube. There are 6. So if we look here, 1, 2, 3, 4 individual faces. 4 individual faces here are going to be colored red. So we know that if there's 4 there, 4 of each of the large faces, that's 4 smaller faces are colored red. There are 6 large faces made up by 4 smaller faces. That means 24 of the 1 by 1 faces will be painted red. 24, the smaller cubes are not, 24 are painted red, okay? So now we take that and we have to find out how many are not. Well, how do we do that? How many total cubes are there? There are 8 total cubes. 8 times 6 is 48. Okay? 48 minus 24 would be 24 are not painted. So there's 24 painted red and 24 not painted red. Another way to visualize this, let's just look at one of these corners at the vertex. Okay? Let me blow this up so you can see it. Blow the square up. Another way I like to visualize this one is on this particular cube, 1, 2, 3 of the faces are painted red. The inside 3 are not. So half of each cube is going to be painted red, half is not. So you can see the 3 faces there. Okay? Or you could take and go, okay, how many faces do we see? This is half of it because there's 3 of them. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 more on the back, so that's 24 red. And out of 48, 24 are not painted red. So the answer, 24 are painted red, 24 are not painted red. The question actually asks how many are not painted red, and that would be 24 as well. Okay, 24 faces. Okay, that one question was asking about more of your knowledge of edges and faces than it was volume. All right, I think we're ready. You're going to be doing homework and remembering 6.1. Oh, what am I talking about? Let's first review the 2 formulas for volume. Okay, the first one, volume is equal to length times width times height, all 3 dimensions. Sometimes you'll have length times width times depth, how deep it is, but still, it's that 3rd dimension, whether it's how high or how deep. Okay? When we combine length times width, that gives us the base, the area of the base. And when you have a capital B stands for the area of the base. So a lowercase b is the base. That's one side, like of a triangle. But when it's a capital B, that's the base. That's going to be an area. And then we just multiply the height times that. Those are the 2 formulas for volume. Now you're ready. Homework and remembering 6-1. You're going to be doing a lot of story problems and reviewing some fractions on the remembering page. All right? Do your very best. Good luck. And I expect you to work quietly while I'm gone. Now, get your work done. Here it is.